Yes. That's that by the way. So let's move on. So R squared and adjusted R squared method are used to check the model accuracy or the accuracy of the model, the accuracy of the model. So R squared can be calculated by using this. So R squared is 1 minus sum of square residual over sum of square total. So if we talk about sum of square total, sum of square residual is what we have seen in the previous slide. So here, sum of square total and sum of square regression are the total sum of square and the sum of square of errors respectively. So you have already learned about SSR, which we have seen in the previous slide. So let's see the next slide. Now, adjusted R square is calculated as this. So adjusted R square. So you have this R square, and this one is the adjusted R square. Now this R square is the R square you have here. So this R square is still the R square you have in the last slide. So this is the formula for finding the adjusted R square. So here N represents the number of observations and K represents the number of parameters. So N is the number of records. Now your K is like the number of observation. I say observation. Number of like independent variables you are considering in that regard. So adjusted R square value has the following two properties. It depends on the number of explanatory variables we talked about, which is your K. So it imposes a penalty reducing R squared for it imposes a penalty for additional explanatory variables. So sometimes maybe let's say forward you have backward process, forward process, or doing your in this case multiple linear regression. So let's say you want to consider predicting a particular variable y depending on your x. So you have different x's. So you might want to start from a particular x that you say it's highly correlated with your y. So you build the model with that one x. So you can say, oh, maybe this x is not enough. You want to add another one. So you can add and keep adding, or you can put all the independent variables. So let me see. I think someone's in the lobby. But we see you see more of that in the next slide by backward and forward process in building your regression model. So what are the assumptions here? So the validity of the regression model is ensured by statistician by-variable model on basis certain assumptions, which are this linearity, which I've said in here, the first instance, that if you are doing a linear, so you are going to assume this. So assumes a linear relationship between the dependent and independent variable. Now, independence, assume there is no correlation in the errors of the collected sample. So assume that there is no correlation in the errors of the collected sample. So in this case, I can say, the x's are independent. So they are not correlated. So let me put it that way. The x's are independent. So it doesn't make sense when you are building a model with two x's that are highly correlated. That they are highly correlated. So it means that one is dependent on the other. So homoscedasticity assumes constant variation in errors, and normality assumes normal distribution of errors in the collected sample. It's normally distributed. So it us also know that complexity of a regression model increases with increasing number of parameters. So the more independent variable you model, the more complex the model looks like. So let's look at this knowledge check here. Building a regression model to specify the relationship between task and temperature. Generally, test increases with the increase in temperature. However, test also depends on calories used by a person. In this case, while building regression model, how many independent variables will you consider? So in this case, you are trying to, what are you trying to specify the relationship between test and temperature? So let's say you want to, okay, so you can see generally test increases with increase in temperature. Between test and temperature, they are correlated. So in this case, test is the dependent variable. So you want to use temperature to measure test, but they said that, however, test also depends on calories. So your x, another x here is coming in, which is calories, which is dependent on the independent, so which is dependent on the dependent variable test. So test is your y, so your x is going to be the temperature and the calories in this case. So you have two independent variables considered. So that's by the way. Also consider the following data. This is our x, this is our y. So which of the following is the correct value of r squared for the given data? So you have to compute that using so probably if you are into the practical session, you can compute what the r squared is here. So multicollinearity. Now multicollinearity is a non-linear relationship between two explanatory variables leading to inaccurate parameter estimate. So if two or more variables representing an exact approximate linear relationship cause multicollinearity. So in this case, when you say, so in this case, it's like you want to be the regression model and you have two independent variables that are highly correlated. So you can't put those two into the model. So you're going to run into two problems. So you have to with this guy. So multicollinearity can be detected by calculating BIF with the following formula. So you can check with this formula. So here Ri is the regression coefficient of the explanatory variable Xi. Sorry, hold on. I don't know who's, let me just put this code. So this person is not serious. So with respect to all so Ri is the regression coefficient for the explanatory variable Xi, particular Xi, with respect to all other explanatory variables. Let's look at some of the effects of the multicollinearity so inability to in estimating standard errors and coefficients, high variance and covariance in OLS cause problems in assessing the estimation precisely. So in a nutshell, you would want to avoid multicollinearity when building your, oh God. Okay, no problem. So multicollinearity can be removed in the following manner: specifying the regression model again, using prior information or restrictions while dismissing, collecting new data or increasing the sample size. So now let's say before building your model, you can try to do what we call PS, like PS of the data. So this is going to do you're going to measure the correlation of each variables. So you're going to do a pairwise correlation. So if you see two x's that are highly correlated, you can just want to remove one and leave the other, depending on so let's say x1 and x2 are highly correlated. Now I want to build it to y. So you can the condition for removing x1 and x2 in this case. So you can see check y and x1, check the correlation. Check y and x2, check the correlation. So if y, the correlation between y and x1 is greater than the correlation between y and x2, so you can just try to remove x2 out of it to avoid this scenario. So working with linear regression. So two numerical variables x and y having at least a moderate correlation being established through both correlation and scatter plot are in a linear relationship. So relation line is used to predict the value of y for a given value of x. So x and y are called explanatory response variable or independent and dependent variable. Your x can also be called predictor variable, where you can say y is called the predicted variable. Play that way. So the condition of linearity is checked by creating scatter plots. Okay, that by creating scatter plot that must form a linear pattern. So the regression line is calculated by using the formula. So you can see y equals to mx plus b. So don't be confused by this guy. It's still the same thing as what we specified the other time. Where your b here is going to be like your beta naught. Your m here is going to be your b. So your beta, so your b here, which is like your beta naught, is the in this case you can call it the y-intercept. So where m is going to be the gradient. You can call it slope too.
Hello, Emmanuel.
Yes.
Please, are you projecting your screen? Because I can't see anything.
Susan, can you see my screen? Hello, Susan, can you see my screen? Or let me just, yeah, just share my screen.
Okay, thank you.
Okay, let me share my screen. So can you see my screen now, Timothy?
I can't still see. Maybe it's an issue from my end.
I think it's your. Maybe you should check out.
Okay. Susan says she can.
Okay. So I think it's your network.
I can see from my end.
Okay. Okay. I'll try to reconnect. Maybe it's my
yeah.
Net.
Okay.
So you want to plot the regression line. Now the regression line is going to pick the highest possible data points that it can link to. So it's like a straight line. I want to do a straight line that picks most of the data points. So it is that line that is used to measure what we call the sum of square error. So it's like, okay, what's the distance between the observed points and so what's the distance between the original point and the estimated point, which is the regression line. Sorry, let me just disturb me. I don't know. So okay, Timothy, can you see my screen now? Hello, Temtari. Can you see my screen? Is Temtari there? I think Temtari is on hold. Okay, let's continue. So, so the best fit line is obtained using the method of least square. It takes a line with the least possible sum of square of errors. So let me put it down. So it takes possible line that has the least sum of squares of error. So what do you mean? Like the line that, so wherever you have it's going to like do some kind of calculation. Okay, if I should put the line here, what's going to be sum of square? We have pick another line. So like it's going to find the best line to do or to fit the model whereby you have a minimum sum of square of error. So that's how the line of best fit is drawn. But if you are doing it manually, when you're doing a scatter plot, those kind of, you can do a scatter plot manually. You can do a point then. It's just the best way to do is find the line that joins most points together. That can join those most points together. You can do that manually. So during the estimation of the value of y, the slope can be calculated by multiplying the correlation coefficient between x and y, the division of the standard deviation of y values by this. All this one you should see the formula in the next slide. Maybe not in the next slide. So, but there's this formula I usually use to calculate the coefficients. I'm just trying to find the black whiteboard marker, but I don't know why it's not working. So, but you should see the formula in maybe in next slide as opposed to. And the y-intercept b of the best fit line is obtained by subtracting the product of slope and mean of x values from the mean of y values. So it's like you are trying to do product of slope and mean of x. That's so product of slope, which is your slope in this case is b times, it's going to be b times x bar. So your x bar is the mean. Then you say subtract product of slope and mean of x from y, so from mean of y value. So you are doing that y bar minus b x bar. So that's why you find your y-intercept b. So you see b is equals to y bar minus m x bar, where m is the slope. So you can use that to find your b. So in this case, that's the case of a simple linear regression. So when it comes to multiple linear regression, the formula can be somehow complicated, but there's a way I used to I'll use the matrix method to find the coefficient. So if whiteboard marker comes up, I can show you how to go about that. Now, in the context of regression, the slope is interpreted from the change in y values with respect to the change in x value. So that's slope for you. So that's like you are doing like what we call let's say y. So let me say y in mathematics, say y2 minus y1 over x2 minus x1. So the way y changes and over the rate of how x changes. So that's how you find the slope. So the y-intercept, which is our b, which is sometimes variable and sometimes not, as I said. So is the place where the regression line crosses the y-axis, where x is x. So it's like if I draw, I don't know why this thing is not this way from coming down. I don't just know why. But it's looking like it came up here, but I can't just see. But I'm opening app now. It's not app, I'm opening it. This is the app now. Opening app. Download the Microsoft Whiteboard app. Wow. Yeah, download it. See, I don't know why I'm using the Microsoft Teams app. They are telling me to download Microsoft Whiteboard So let's proceed. Maybe so this is what I'm talking about. So this is the whiteboard marker, but I can't just see the marker itself. Let me scroll. I can't see the marker itself. So let's just continue. So it's like if I draw your XY plane, then the straight line, so it's where the straight line crosses the y-intercept. That's where you pick as your y-intercept. Let's say, which is B in this case, which is this particular B in this case. So it's the point at which that of it crosses your y-intercept. So let's move on. So simple linear regression simple calculators are not fit for large and complex calculations involved in linear regression, therefore require a tool for the purpose. So how is a popular tool used in this case? There are 5 famous functions which are mentioned as follows: sum x, sum y, sum x squared, sum y squared, sum xy. Now this guy, you use it to there's this formula of finding your m, that's your gradient and your y-intercept. You might need all this information. What are your x's? This is your independent variable. What are your y? So okay, sum your x, everything. So that would be sum of x. Sum all your y, that would be sum of x. Then square x. So take the square of each x's. Then find the sum, which is this. Take the square of each y. Find the sum. Take the product of x and y, put it in a particular column, then sum it. So all this summation will be useful in calculating your SSR, your whatever. So as you can see, SSX, SXY. So for SSX is this formula where you need your x square, you need your summation of x, that's the total of your x, is the total of your x square. So before I continue. So the famous 5 functions are used in various calculations that perform regression. So one calculation is the regression. The regression is calculating of corrected sum of squares. The formula of corrected sum of squares of x is this guy, while the other sum of squares can be calculated in a manner similar to above. The calculation is sum of products using the formula. So sum of products xy, you have this formula for it. So the difference between this SSX and XSY is that this one to be x squared, and this is x times y. So this is like x times x. This is now summation x times summation. This is your summation x squared. So in case of x, I now have summation x times summation y. So all things being equal, this over n, this over n. So that's just the logic behind this guy. So if it is SSY you are looking for, so that will be summation y times summation y times y, that's summation y squared in this case. And this one will be summation y all squared. So let's see. So your sum of square error, which you've talked about in the previous slide, that's your observed. This is your observed value y minus the estimated value, which is a plus bx. Then you square it. So this is like your summation of e squared, which is the error term. So you just call it SSE. So the lower the value of this guy, the more accurate your model is performed. So the degree of scattered, the degree of so the other calculations in regression are the analysis of variance, the unreliability estimates of parameters. After calculating the values, predictions can be made. So I think that comes to the end of this slide. Let's see the next presentation. So let's take for example, a regression model is developed to predict the marks of the students on the basis of the number of hours studied and the number of lectures attended by him or her. So the regression model is shown below. So you have obtained marks is your constant variable plus your coefficient of a particular x, which is number of hours studied. So this is the x1. Then you have the coefficient for the x2, which is number of lectures attended. So you want to use the number of hours studied by the student and the number of lectures attended by the student to calculate to predict the mark the person is going to get maybe in the exam or the test. So the following table shows the data collected from 4 students. So yeah, so after you have done you can see that the beta naught is constant for all the students. And you have number of hours studied. This for the particular for Jackson, this for Mike, this for Jelly. So this is like after you predicted the model, then B1, this is the B1, this is the B1, this is value of B1, this is the value of number of lectures attended, this is your B2, then that completes the model. So by the time we do this plus this times this plus this times this, and you have your predicted value. So as the predicted value is not here, they didn't put it here. So this is going to give you your obtained marks. Your obtained marks. So on the basis of the regression model and data, which of the following is the correct sequence of students if they are arranged in descending order of the predicted marks? So it means that you are saying that Jackson has higher marks than Lisa, Lisa has higher marks than Mike has higher marks than Jerry. So for you to answer this question, you have to find your predicted value here. So the predicted value for Jackson will be this is your B naught plus this times B1 plus this times B2. So you have a value for Jackson, then you have a value for Mike. So let's say you want to use the calculator to do that. So why is this? So let's say you want to use. So this is. So let's do. Here's my calculator again. So let's say 9. By the time I don't waste my time on this. By the time do this plus this plus this, then you find the level for Jackson, then you find for Mike, find for Jerry, find for Lisa. You'll be able to know the correct sequence in the same order. So in this case, they marked this guy to be the correct answer. So by the time you do your computation of the other, and you'll be able to say which is actually correct. So let's move on. So in regression analysis, SSC is calculated with the help of the following equation. So y is the predicted, the observed value, and a plus bx is the predicted value. So by the time you subtract y from a plus bx, you have this, then you square it, then you find the sum. That will give us SSE. So where the symbols and coefficients have their usual meanings. So in case of the given equation, which of the following is the correct expression for the value of the slope of b? They didn't give us they didn't give us the formula for it, but they are saying that s is sum of square of xy over some square of x will give us the value for our slope. But in the previous slide, they talked about b to be y bar minus m. Okay, this slope. Oh, okay, this slope. The one they gave us was for the intercept, which is y bar minus what we call it bx bar, mx bar, where m is slope. So for the value of slope, you have ssxy over ssx. So you can use those expressions we are given. SSY, to calculate the value of SSY, that would be summation xy minus summation x times summation y over n, where n is the number of observation. So let's keep that in mind. But me, I have some other way of calculating this results. It's not that this like whiteboard marker is not coming up. So linear model results objects. So let's see. So simple linear regression is similar to correlation with one predictor and a response variable. So we use LM function for this kind of linear modeling in R. So let's say we want to a data set named FW having 2 columns that can be correlated is taken to implement the LM and summary function. So to build the linear regression model, use the LM function. So you are trying to build a model having y as your dependent variable. You are modeling y using this x. So your y is the count, your x is the speed. So you are using the data called FW. So this performs linear regression analysis for the count and the speed data. So you assign the model to fw.f. So using the summary function, store the results in there. So you use this to find the summary of this this model. I don't know why they are putting fw.lm here. It's supposed to be. You are finding the summary of this guy, so it's supposed to be fw.f. So the names command is used to view the other details contained in the result object. So you can use names of fw.f in that regard. So we are going to go into the. I can use the R environment. I think I should have this data set. Let me check. Dr. Abeng, did you receive the data set I sent? Dr. Abeng did.
You are asking me?
Yes.
Oh, okay, I did.
Okay.
So, thank you.
Yeah. I can't find the FW data set here. Where's the picture? Maybe we can do a particular session. So let's see the next slide. So the components can be extracted using the ampersand syntax as follows. So let's say the model you built, you can see that they wrote fw.lm here. So this guy was supposed to be fw.lm. So it's like their own mistake from that guy. So if I want to get the coefficients, so this is going to fetch the coefficients in that regard. So it's a simple linear regression model. So this should give me beta naught and beta 1 respectively. So where beta naught is the constant value and beta 1 the coefficient of speed in that regard. So you can also use this guy to find the coefficient. So COEF of the model. So you can use this to fetch the confidence interval of the model. I believe you understand the concept of confidence interval. So now, so this is used to extract the values of the regression model. So this is going to fetch the predicted value. So this is going to, you are going to see the predicted value that the model actually predicted. So this shows the procedures of the regression analysis. So this is going to show us the formula that we use to build the model. The formula which is this case, this guy. So the confidence interval of the coefficient can be obtained by using the COFINT command, which you have seen in the previous slide. Now, stepwise model building. A regression model is built by using 2 strategies. We have forward stepwise regression and we have backward stepwise regression. So in forward stepwise, first of all, you can start with maybe a simple linear regression. So you have a a variable y you want to predict, then you have several independent variables. So you can start from one particular variable, maybe the one that is strongly correlated with a y. So you start by using that to build the model. If you see that the model is not really performing well, you can add another variable by using this command. So forward stepwise. So you keep adding until you are satisfied that the model is performing better than the previous case. There is backward stepwise deletion. Now this one is like, oh, you are doing all in. So you put all the possible independent variables that you have into the model. Then you keep dropping, checking for significance of the particular variable in that model. If it's not significant, you drop it using drop one. Then until you have a good model, so let me put it that way, a good model. So adding times with the forward stepwise equation. So this is the command. So let's see, using add one command to add value. So you add one, then this is the model, then this is the model. So this guy, then showing the results. I'm going to see the summary. So depending on the maybe the sum of square error, then keep adding and the likes of that. So there is when I did something like this, I use the backward stepwise deletion. So I did that one in Python anyways. So we should see as that goes on, we enter into the DASCA class. So let me see this application. So you can also use this then suicide test, which is the Fisher's test. So removing terms with backward deletion, then you use the drop one. So first of all, you beat the model here. So you can see here when I beat the model, I'm trying to predict the length. Then I put the what's the sign? What's the sign called again? Then I put this sign. Since I'm building, this is my y, I'm modeling y with respect to, and you put a dot here. I put a dot here means that you are considering every other variables in that data set called ML. So you are putting all those data as your x's, as your independent variable. Then you can now keep dropping depending to drop one, put the model, put the test you're using to drop the model, and drop the variables. There you go. So you use ANOVA command to compare two linear models. So two linear models can be compared using the ANOVA. Then you say, okay, this is the first model you built, then this second model you built. You can do a comparison check as which is performing better. So now let's talk about the curvilinear regression. So curvilinear regression is a mathematically defined linear regression analysis having no straight line form of relationship. The regression is estimated by adding more predictor variables in the multiple regression formula. So the typical equation is this. Now look at this guy. This is like a kind of polynomial function. So it takes the form of multiple linear regression, but it's not actually multiple linear regression. Let's see this one. Y is equal to m1 x1. Now I have to be m2 x2, m3 x3, then plus c. So it's kind of looking like multiple linear regression, but it's not. So it takes the form of similar to the multiple linear regression. You have a logarithmic relation. This one takes the form of multiple linear regression. So you have a logarithmic relation can be expressed by this. So you have y is equal to m log the log of your independent variable, then plus the intercept. Now this is not linear. This is not linear. So we have a log function coming up into your model now is not linear any longer. This one can look like it's linear, but it might not be linear. So by the time we draw the scatter plot, you should be able to see that. So the scatter plot is kind of tool you use to see how the behavior of your data set is, or your model is. So you should be able to tell that, my friend, this, you can see this does not have a linear relationship. Now let's consider the following commands. Write another command to compare the given results yesterday. So you can use ANOVA to compare the model. What are the points to remember here? So regression analysis is a statistical tool used to determine the relationship between different types of variables to help analyze how the changes made in one variable affect the behavior of the other variable. So in the case of your independent and independent variable, in this case. So linear regression can be of two types, which is simple and linear, and we know the difference between the two of them. So it also find the relationship between a continuous dependent variable y, known as the response variable, and continuous independent variable y, known as the predictor variable or the explanatory variable. Regression analysis is implemented to do the following: establish a relation between the x and the y variables, which is independent and dependent variable in that regard. We do the value y based on the set of values x1, x2, dependent. So if you have one single x, we say it's simple. Identify independent variables to understand which of them are important to explain the dependent variable. Multiple regression is a statistical technique used to obtain the value of dependent variable from two or more independent or predictor variable or explanatory variable. So a multiple regression equation and single regression equation are both defined by using the least square method. Regression models are used for predictions. For appropriate predictions, it's better to first check the adequacy, checking how good or accurate your model is of these models. So these are the four basic assumptions: linearity, independence, homoscedasticity, and normality. We talk about multicollinearity. Then you have what we call the R squared. You have what we call the adjusted R squared. Then you have all these functions that are important to calculating all these sum of square residual and sum of square. Then the LM command, which is used to build the linear model, and the two types of two ways of building a linear regression model. We have the forward stepwise regression and backward regression method. So a simple example of linear regression is the relationship between the length of carapace as upper shell of a tortoise body and x given by a tortoise. Upper shell. So on the basis of study, the relationship between carapace length and number of eggs are expressed in terms of quadratic equation as this. So a quadratic equation is not a linear equation. If you draw the graph, is going to be in form of a curve. So where A and B are the regression coefficients that depend on the sample data. So that brings us to the end of the linear regression. But let me see tableau public. So this is tableau public. Are we here? Let me go into the lab before I go into visualization. So let me open my VMware. Hello, Susan, are you still there? Just give me a minute.
These things we are doing, are they in the manuals you gave us?
What is that, sir?
what you are treating now, is it in the manuals you get?
What am I treating? Linear regression.
Whether they are in this manual.
Yes, they are.
I couldn't find them. Which section are they?
Sorry. Back. Okay. So okay, so I just let this one. I do. Actually, do this out. Let me just. I can just do this in out. Let me open my house to do that. That's like what the. Okay. Go down. So is this thing not coming up? So let me do it. See, we should come up now. I think I won't have to wait for this guy to come up. So ask me later. Has come up. My ask to Chief does not want to respond. I think it's fine. I don't know why my system is lagging like this. Let me check my laptop. So let me just use this. If that one is not, it's just misbehaving anyhow. I think it's good. It's just taking time. Even the virtual lab is taking time to explore. So okay, I think you have it now. Can you also see my screen? Hello, can you also see my screen?
Yeah, I can.
Okay, let me first of all check my current open directory. Why is it taking that to get everything? Okay, so I think I have documents as my current open directory. So let me check where my data is. So I'm using this data set. I have one data set. Petrol consumption .csv. So let me see whether I have this in here. Petrol consumption. I'm checking data sets. Okay, I think this is yeah, petrol consumption .csv. Let me just copy this into documents. But I won't actually try to navigate to the location of the data set. Well, you're taking time. So let me just copy this. And my slow down this moment. So petrol data, so petrol data is just a read.csv. Then let me just go to the location. Since it's under desktop, so I just put desktop here, then put it's under the, so what's the name of the data again? That's petrol consumption. Okay, then slash petrol consumption slash petrol consumption. I'm using our cancel .csv. So let me just run this. What's what is this one coming up? Okay, so let me see the head of the data. Head petrol data. So these are data sets. Okay, so I might want to check the summary about data sets. Data, the summary about data set. It contains city index, petrol tax, cents per gallon, average income in dollars, paved highway miles. So what's the background of this data set? So Lewis, let's say Lewis Rodriguez is the owner of petrol filling station or the petrol filling station. So he data on petrol consumption in major cities over a period of time. So it collected all this. So you have city index. So I think maximum of city index is 48. So let's say you collected information across 48 cities. So you have all of this information. So let's try and do a plot. So let's try and do a plot or find a correlation. Just find a correlation between data.frame of petrol data. I want to call petrol tax. So I want to call petrol tax cents per gallon, comma, sorry, comma, petrol data, petrol data, ampersand, say average income dollars, then petrol data ampersand, the poor proportion of driver's licenses, then petrol data ampersand. Let's see consumption in million per gallon. So I want to find the correlation between these four columns in this petrol data set. So I'll convert the data frame, then do a correlation. So let's go on this. So you have a table format. So this is the correlation between tax cents per gallon and taxes per gallon. It's going to be a perfect correlation because you are comparing the same column. So this correlation between average income dollars and tax cents per gallon, which is 0.086, which is a very low correlation. But proportion of driver license, proportion of population of driver licenses and tax per gallon is minus 0.63. This is a negative correlation. It is a moderate negative correlation. You can say this is a moderate negative correlation there. But if you check the consumption in millions per gallon of petrol and proportion of population driver license, you have to be 0.858, which is a strong positive correlation. You can see this one is a strong negative correlation. That's the million per gallon, consumption in million per gallon, and the petrol tax in cents per gallon. So we have this information about their correlation. So let's try and plot. Let's try and plot the proportion and consumer in million per gallon. Let me check that. Proportion in population driver's license and consumer good per gallon. Now, why I'm doing this because you can see that it has a strong positive correlation. So you have to try and check this guy, try and plot this guy, and this guy. So let's try and do that here. I'll try and plot it. So So petrol data percent proportion of population driver's licenses and petrol data and is it consumer millions per gallon? Yeah. So let's put a color. So let me put it as red. So color. So then put it as red. Let's run this. So why this one? I don't want to see. So you can see the plot here is going. It's like an upward kind of movement. So it's going upward. So it's like a positive correlation. So you can see why the result of the correlation is 0.858. So it's a strong positive correlation. As you can see in the scatter plot here. So you can compare that with scatter plot. So let's do build a simple linear regression using these two information, which is the so we would like to predict build a linear model that is going to take the consumer consumption in million per gallon, a million gallons, and proportion of population driver's license. So let's call that petrol reg is equals to LM, which is the command to build the linear model. So petrol data percent. This is going to be our x variable. So that our y variable, which is what we want to predict. So let's go petrol data. So we want to use the proportion of population driver's licenses to predict the consumption rate. So then let's run this. So we build the model and assign it to this variable. So let's call the model petrol rate. So this is what we have. So in here you have what we call you can see you have the formula here, which is y building y using this particular x. So these are the coefficients. This is the intercepts. This is like your beta naught in that case, and this is your beta 1 that corresponds to the coefficient of the driver's license, which is your x. So this is the formula that I used to build the model. So in this case, you want to write the model in words mathematically. You are going to say y is equals to 161.4 plus 656.9 x times x. So your x in this case is the proportion population of driver's licenses. Right, this is your constant value, while your y in this case is the consumption in million gallons. So this is your model in mathematically using the coefficient. So let's check the summary of the model. So petrol reg. So you have this information about the residual. This is the formula. This is the final mass of the residual. This is the coefficient as you have seen in when we called the function before. So this is standard error corresponding to your intercept, corresponding to the coefficient of the x. This is standard error in this case, the error time. So you can see residual standard error to be this of 46 degrees of freedom, because you have how many data points you have? 48. So you have your R squared value to be this, and your adjusted R squared to be this. So you have your official state statistics to the all of this. So you can see the summary about the model here. So if you want to see the coefficient of the model, you can use this guy. You put the model name here. You can see which is what it returns when you call the model itself from this place. So you can see the coefficient. If you want to check the residual, you can do this receipt, then pass the model into it. So this is the residual of each data point. So you know when we build the model, when we want to write the model, this is the way you write it. Y is equals to, I want to use B as my constant function plus M, which is the slope, X plus what? Plus E, which is the error term. So this is the error term that corresponds to each data point. So the error term for data point 1 is 17. So which one has the minimum error term? If you just neglect the negative value. So considering that this is going to be the this guy minus 3.19. So this one has a very low error time. So it means that the value of this data point 8, the prediction for this data point 8 is very, very close. It's very, very close. So if you want to check, the data points, the predicted value, you can use fitted, then virtue, then pass the model name here. So these are the fitted value. These are the predicted value of the model. So let's check the observed value. What's the observed value? That's we can use. You know y is what we are predicting. So what are y? This guy. This is what we are predicting. So I'll just come here and put it here. Let me run this. So this is the observed value. So if you check for data point 8, this is the data point 8. 470.19.59. So let's check the 8 data points here. 1, 2, 3, 4, 5, 6, 7, 8. You can see you have 467 here, which is very close to what? 470. This is the point 8 here. This is the point 8 here. So you can see that this value is very close to this one. So that's why you have a very minimum error term here. So if you see that, if you add this error term to this guy, if you say this minus this now, neglect the negative value. If you say 467 plus 3 point this thing, you're going to have the exact time here. So do you understand the logic now? Are we still there? Hello?
I'm with you.
Emmanuel, I'm here.
Okay, Susan, are you there? Okay, Susan, are you there? I need to what's going on? What's going on? So let's move on. So let's see. Look at this guy now. Value. So so I want to predict another. So if you see there's another one. If you check the correlation, when we check the correlation here, you can see the other one that's actually correlated is this guy. Where is it again? The consumption in million per gallon and the tax cent per gallon. The petrol tax cent per gallon. So it's strongly negatively correlated. That's strong negative correlation. So you can try and build another model that is going to use the petrol tax cent per gallon to predict the consumption in unit per gallon. So let's call that one petrol reg 2. So let's call it petrol reg 2. This is another model we are building using that variable. So we use petrol, not build petrol data, not predict the consumption in unit per gallon with the tax cents per gallon. So let's build this model using this. So I can call the second model we just built. This is the coefficient, this is the intercept. Then the coefficient of the x is minus 56.05. And also check the summary, blah blah blah. You can also build a multiple linear regression model. So let's say you want to compare these two models, you can do over and put the first model and put the second model. So you performed so you can see the result here. This is the residual for the first one, this is the second one. But you can see that in this case, you can see that the first model is performing better than the second model, which is actually obvious from the correlation. So it's performing better than the second model. So you can also build a multiple linear regression model. So let me say I want to build a multiple linear regression model using this same data. So let me call it petrol multi-reg. So LM. In this case, we want to still predict the consumption petrol data. We want to predict the consumption using the driver's license, proportion of the driver's license, and so you put a plus sign, and we want to also use the tax in cents per gallon. Then we want to also use I think have I used license? I've used license. You just want to use those two. You just want to use this. Let's just use those two. So you have two independent variables and one dependent variable. So let's run this. So we have built a multiple regression model. So let's check the summary of about multiple linear regression model. So this is summary. So you can see here, this is your intercept, your constant value. This is the coefficient for the first regression independent variable, which is proportion population of driver license. This is the coefficient for the second independent variable, which is tax set per gallon. So you have your R squared value to be 0.791, adjusted R squared to be this. So let's see the R squared of this multiple linear regression, which is 0.791. Let's check it with the first model we built. This is 0.7364. This is so the first one is performing better than this, even this multiple linear regression model. So that's how we build the model. So that is by the way. Let me see. I'm missing something. I think we explored how to about that. Is there something I missed? Okay. So let's talk about how we talked about different way of building a model, that the forward, stepwise, and backward relation. So let's see. I want to install a particular package. So before I do that, I want to install a particular package. It's really necessary. Hold on, please. I didn't know that I have this. So I'm checking. Let me check for a particular data. USA. Let me check whether I have it in my. USA. Let me check the additional data set. So okay, let me add another variable to this. So let me add another variable to this. Since I want to add more variables to it. So I've added tax cents per gallon. So let me say I want to add average income dollar. So I have three variables here. So I have this guy. Let's check the summary. The aspect is even bigger. So let's say I put three model here. But let me build another one whereby I'm going to add all the variables inside this. So let me say LM. So I can just put first of all the Y variable, which is consumption unit per gallon. Then I can do this. Then I can put. If I'm going to put a dot, so I'm building the model based on all the variables in the process. I have to specify the data I'm looking for. Let me just remove this ampersand sign here. This. So I will say data is equals to, what's the name of our data again? Petrol rate. Okay? Petrol data. Yeah. Petrol data. So let me check. So I build the model. Yeah, our Y is the consumption in unit per gallon. Then our X's are all other X's, all other variables in the data. So let's check the summary. Oh, sorry, I don't want to give you this name. So let me call it all. Let me put all here. So I'll say that this is the model I use considering all the variables. So, okay, that's good. So let me check the summary of that. So, as you can see here, you can see you have city index, as an X variable. We use tax cents per gallon, average income, lived average miles, proportion, population, driver statistics. So all the variables are now all in. So we can now use this function as described in the class. So let's say we want to be removing variables from all these less variables from the model as we proceed. So you can use the drop one or the add one function. So let's say I want to use the drop one. So let's say drop one. I don't know how to check. So what's the name of the model? petrol oil rig. So let's see. So you can see here we have this result. You have RSS. This one is not. This is the constant value. Then this is another. This is the city index independent variable. This. So you have all these independent variables. So this is going to give us an hint of what is the variable you ought to remove from this model. So it's going to give you an advice as regards that. So the first model we built, we use tax cents per gallon. Okay, no, we use proportion population driver's licenses. Then we use tax cents per gallon. So if you look at this proportion population tax cents per gallon and this. Now if you check the one with the least RSS, so the one with the least RSS here, you are going to remove it, which is the city. No, sorry. No, this is the constant value. Just leave the constant value. So first of all, you can come and remove this guy. So you can remove this guy. So we are going to build. So the model we are going to build now, we are going to remove this guy from it. Then build the model again. So this average income per dollar, we are going to use this guy to move from the model. So we are going to use this guy. So the next model we are going to build is going to be without this particular column, which is average income index. So I will just copy the whole of this now. I'll copy the whole. Let's use average column index here. So without wasting much of our time. So what we just do is that we want to build the model now. You are going to put all other variables excluding this particular guy. Then you can do the drop one again to check for the next column you feel you should remove from the model. Then keep continue that process until you are satisfied with the performance of the model. So that is how you do that. So let's say this guy, for example, this first guy we did here, petrol rig, this is the first model we first built. So let's say, okay, you want to see the kind of variable you want to add to this guy. So you are not satisfied with the performance of this model. So you want to add another variable to this particular guy. First of all, this guy is having only one independent variable, which is proportion population of driver access. So we can use the add one. So use add one now. Then put the model, which is petrol rig. Hold on. Okay. No terms in scope. So I have to put scope. What should I put in scope? Let me check again. So, let me check the scope to do this. So I have to add a scope as regards the scope parameter. So let me check. Where is it? Or is this? Yeah. So the add one, okay, yeah. So scope. I don't know what this MF is. Okay. So let me use this. Let me use this to perform the adding of variables. Okay, so let me put MF. So let me run. I'm still having error. Object MF not found. Let me check again. What is MF? Okay, I think, yeah. So MF is the data. So MF is the data. You have to specify the data you are. So that would be virtual data. Virtual data. What's happening? Error impactor. The scope. R factor as them NE not included in model. What's wrong? There is something wrong somewhere. Choose the adds a value to the MF object. I don't. I don't. Uh, let me check. Let me see. So I think I'm going to come back to that again. I'm going to come back to that again. So we've already explored how to do simple and multiple linear regression without wasting much of our time. So the next thing we're going to do now is let's explore the Tableau environment. Then we move on to the next session. So we shouldn't take much time on this. So Susan, have you installed this guy now? Are you done with the installation of Tableau? Susan? Hello? Is anybody there?
I think Susan may be having issues with her mic because she drops messages when she wants to respond to you.
Oh, okay. All right, no problem. So let's just move on. So first of all, we try and connect to the data we want to visualize. So let's try and connect. So this is the connect option. So what I want to put to connect it is Excel kind of data, like maybe it can be CSV file. So I want to connect to that. So I click on Microsoft Excel. So there is this data set I want to use. Your superstore. I think you should add it in your data set folder that I sent. Let me go to desktop, data sets, superstore series. So, they call it your superstore, but this is superstore state. So let's just open it. So it's processing. So let's just wait. time. Okay. So, okay, I think we should have our data in just a few seconds.
Iman, what are we doing now? I lost track.
So you just want to do a bit of visualization in Tableau. So just to introduce us in Tableau. So we imported the data set called the Superstore data set. So these are the data sets looks like. So we have the row ID, other dates. So automatically Tableau recognizes the data type for each column and it just picks it up from there. So row ID, you can see this is the number. They have this hash sign. It represents the number. You can change data type if you feel like it's not the appropriate kind of data type. You can change it. So you can just click on this guy there and say if it's a string or. So this is a date format. You can see this is a string that we have the ABC string. So you can see this identifies this guy as a location. That's why you have this kind of map kind of format here. Identifies that as a location. So you have all these columns here. If you are good, you see you want to add more data, you can do that. So let me see. So I think okay, there are still more columns. Okay, as you can see here, there are still more columns as you can see, as you can see, as you can see. So if you think you are good, then you can proceed. So down here you see what we call first of all, so down here, so if you feel like you want to add, you can say new data source, blah blah blah. So if you are done with importing your data, then you can come to this place, go to worksheet to start doing your visualization. If you think you still want to do some manipulation on the data sets, you can do that from here. So let's say from I can create calculated field, I can create group, whatever. So let's just go to sheets here. So you can see go to sheets. So you can see here, say add new sheets. You add dashboard here, you create a story. So let's go to sheets. So after is the sheet one. So in sheet one here, you have this here you can drag and drop columns and that's it. Sheet one. So in here you have what we call dimensions and you have measures. So these are dimensions, these are your measure. Um, in 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 real mapping, just like maybe your categorical view and your continuous view. So let's have a simple visual. At my right hand side here, you have the different kind of visualization you can do, but you can't access this guy unless you drop some stuff to the visual environment here. So if you click on this guy, you are going to see some kind of description, 0 or more dimension, 1 or more measures. So let's say we want to perform a simple line graph or a line graph. So let's say I want to use the product category, or let me just do the year date. So I want to do this. Hold on, let me admit someone to the class. It seems Dr. Ben. Wow. Okay. Dr. Ben is back among us. So so let me use this column.
I am back.
So let's see shift this. I want to use shift this. I can drop it on the column. So just the column and so drag and drop can use it. Where is it? So this is the shift date. So you have to 2019, 2010, 2011, 2012. These are the unique dates we have. Let's say then. So I want to see maybe sales. I want to see sales in each year. Then I can just drop this one at the whole year. Then automatically it does what we call a line chart of something. You can say you don't want this kind of one. You can say it's this guy you want. When you have something like this that extends it. So 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 I have this guy, or I can say with this guy you have this short format. Now let's say I want to do something like this. Let me check this one. So I want to do it quarterly. So I can just, okay, as you can see there, I just click on this guy, then click quarter. Then you can see it's already explained quarterly. So you can see 2009 first quarter, 2009 second quarter, third quarter, fourth quarter. You have 4 quarters in last quarter. So 2010, 4 quarter, 2011, then 2012, which is shown in this graph as it is. So automatically, if you do this guy, it's going to give you sum of sales for each quarter. Now, you might want to do, I don't want to do sum, I want to do average, the average sales in each quarter. Then you can click the drop down, then change your measure to average, then you have the average sales for each quarter. So it's quite very flexible. You can give your sheet a name. You can do so many things. So let's say I want to do a bar chart. So let me just go to another sheet and to do another visualization. So I have an empty sheet like this. Let me, if you want to do a bar chart, you are doing comparing like categorical variable and the account. So let me choose product category and drop it in rows. So if you drop it, you see a table format, something like this. So you have this product category. So let's say I want to see the profits I have for each product category. So you have the category furniture, office, and technology. So if you don't want it to be in this format, if you want your product category to be as column, you can drop this and put it as column. You can have like this. Then you come to I have profits here, then drop profits here. Automatically it's sum. So you have this guy. So this is the profit, sum of profits for each product category. Automatically, if you don't want the sum, if it's the average you want, you can specify with the median. So you have this guy. Now you can say, okay, I don't want okay, let me just leave it for now. So if you say you want to do by subcategory also, so you want to find the profit by subcategory, you have subcategory here. You can just come here and drop these guys. You can do it side by side. Something. Let me do I should have something like something I want to do. So I'm just click on this guy, which I can use one or more measures. So let me I can't use this. I don't know why it's giving me this kind of. First of all, let me remove this sum. So let me see how my table looks like. Oh, sorry, I dropped category again. So let me put profits. So I'll remove this guy. So the same thing I dropped. So I want to put that subcategory. So you can see what I have here. So this is for furniture. You have this subcategory. You have chairs and furnishings. You have tables and bookcases. For office supplies, you have this subcategory. You have appliances. You have binders and bind accessories. So you have the product category by subcategory. So you have this kind of plot, which is actually good. Now let's say we want to do another kind of plot like a area chart showing the plot of maybe the profit by each country or province. Yeah, you have province like that. So let's go to another empty sheet and do something similar. So in this case, now if I should do something like, if you go to provinces now, if you go to provinces here, you can see that I don't really have anything. So first of all, let me try and do something. Let me drop provinces here. You can see what I have here is I have the provinces here. Good, I have the provinces, but it's not the format I wanted to be in that regard. So let me do we do regions too. Though it's their location kind of data, but I don't have it the way I'm supposed to have it. So let me so I just double click on provinces, then I can see a generated longitude and latitude here, as you can see here. So it's showing me that it is unknown. Showing unknown. So let me see. Let me click on this unknown tab. Otherwise, it's coming up. So let me click on this. I'm seeing unknown tab. So let me see edit correct your own information. So as you can see here, we have this issue coming up. What do we have here? It's fixed. It's fixed in Nigeria. I don't know the kind of location you have. Just select none. I don't know where the locations are, whether it's Nigeria. So I'll just select none. Then I do this. Then I'll okay. So I think this should work fine now. So after I've done that, so I have the map format kind of the thing I really want to have. So these are the locations that I have. So what do I want to know about these people? So I might want to know the orders. Maybe I have the order. I want to know the profit I have for each. So let's say I want to know the order quantity. Let me go to my data again. Let me go to my data source. Order quantity. So you have these orders in those particular province. So let's say I want to know the order quantity. So I can just select order quantity here in measure. I can drop it in color, I can drop it in size, I can drop it in label, but I don't want to drop in color. So if I drop it in color, so you are going to see this kind of result. So here, now if you look at this, the more darker the color is, the more high the order is in that particular region. So this one has more orders compared to all other regions. So in this province, you have Ontario, you have 46,685 orders. Now, compared to this place that is light, you have 1,962 in Nuna bot. You check this province, this is also Nuna bot. So this province, Nuna bot, they have the same color. So if you check this one, this is Northwest Territories. If you check Northwest Territories, they have 9,722. If you check this one, Yukon, 13,000. So if you check this one, 28,000. Check this one, 22,054. So this is how it's going to look like. So let's say I don't want it in color, I want it in size. I can move it from color and put it in size. Yeah, but this is not going to look catchy. So this one is going to do a kind of draw a kind of shape. So the bigger the shape, the bigger the order. Look at this one. This one is the biggest one, and this one is very small, as you can see here. So if you want to do it in label, this is how it's going to look like. It's just going to give you the count. It's going to give you like a dot, then it's going to give you the count of each order, like the total. So you can see it in numbers instead of in colors or in size. So let me just put it back to color. So I think it looks very beautiful here. So as it is now, you might want to also see the label. No, seeing it like this now, you have to hover your mouse on each country to see the province name and the order quantity. You have to hover your mouse on it. So I don't think it's really cool that way. So if I want to see the density of the color, and I also want to see the value of the order quantity in each province. So I have to I'll move that order quantity on label again so that I can see the value again. So you can see on each, you have the value on each color. So you have for 6,695. Are you guys still following?
Yeah, I am.
So you can see the values of each region, each province on all of them. Now it also looks cool like this. I can see the value, whereas I can see the density of the color. I also want to see the value, no, the name of the province. So how do I do that? I'll just move province, this province. I'll move it on label also. So you can see, you can find the label of the province and everything there. So this is the way you go about that. So you have 3 sheets. So suppose you want to add this guy into a single dashboard. So you want to do a report, you just want to show okay, these 3 reports. The dashboard is where you combine 3 reports or 3 sheets that are kind of related. You want to show the relationship between all those information in your pen. So you click on this guy, you can see this particular icon that looks like a 4 square. So you click on this guy, you have the dashboard. So in the dashboard, so this is the dashboard. So in the dashboard, you're going to have you can have multiple sheets on the dashboard. Now you can you shouldn't have more than 3 sheets on the dashboard. By the time it's more than 3, it looks congested and it's not going to look professional. It's going to look cool. So let's add this chart I did. I'll just drag and drop. Then I want to add this one too. I can just drag, you can see. I'll just drag by the side. Then the map that I did, I'll just come downward here to come and add it downward here. So I don't really like the way it's looking like this. So, so let me remove this sheet too. I want to rearrange this guy. So enter view now. Why is it empty standard? So I don't really like the way it's looking like. Let me just so you can rearrange your dashboard like this, but it's not really looking cool like this. How can
Man,
Yes.
I wanted to clear a doubt in my heart.
Okay.
I don't think, I'm just trying to wonder how this can handle very large data. Because from the transformation, you first have to clean the data all. And if you have thousands of data coming in every day, I wonder how you keep cleaning and keep cleaning and keep cleaning every day before you run all these things you are running. And you are doing this on, I think very likely on a smaller data scale, but I don't know, it was just running in my mind. How can, particularly in my kind of job that I have, thousands, averagely 50,000 data points coming in every morning. So how would I be cleaning them and arranging them before running all these things? And most of them come with different entries. Transactions come with different entries. They are not cleanly arranged the way this one is arranged, where you have the regions, you have the state, or you have the sales, you have this. Most data don't come in this clean manner, and the frequency is high. That's my worry.
If you want to clean your data, I don't think, for me, I don't think you should come and be cleaning your data in with visualization tool. So any data you are bringing onto this environment you should have cleaned it before bringing it to this environment. So you can do that cleaning here.
Exactly. We are saying the same thing. For instance, in the data you just brought up now, where your cursor is, there is, for instance, order priority. Order priority is determined by the person doing the analysis. You order it either high, low, or medium. This, I don't know how many machines can do this. So what I'm saying is that at the background, exactly, at the background, I'm not saying doing it here, at the background where the data is being treated or transformed, it's a lot of work.
You can do, okay, let me give you an example. You can do this. Let's say which, okay, let me take other dates now. I can do it, I can create a group now. So what I'm going to do is this. So I'm going to select, let's say I want to group, okay, people, the others are other data between that are in 2019 and 2009. I'm going to a particular year and that's about. So you can select this guy. So let me click on so let me find member. So let's say 2009. Find all. So I can see that's highlighted 2009. So let me now say apply now or click on group. So you can see I've grouped 2009 dates to a particular group. So let me now say group 1. So let me call all the members in 2009 group 1. So that one is, then I'll say I'll enter. So those ones have entered group 1. I can find another date, say 2010. And find, or it's going to find everything in 2010, as you can see here. I'll also group it. Where is this? I didn't find that. So let me find it again. Okay, this is it. I'll edit the group name. This is the group name. So I'll edit the group name here. I'll call it group 2. Enter. Then I want to group people in 2011. I can find this group. Then where is it? This group 2. So as you can see it here, I can give it a name. Say group 3. Enter. So let me close this guy. So 2012. Find the group them, give it a name, group 3 or group 4. Close. So that's all the groups I have now. So apply. So it's going to give them this default name, other date group, but you can put it, you can give it your own name. So let me just give that other date group, then you click on OK. So you are going to check now. If I go to the last column, as if you added to the last column, so you can see the last column in other date group. So this group 2 are the one that belongs to 2010. So you have created another column based on your own. So you are doing like a process. You are trying to do manipulation on the data and all the likes of that. So you can have some. If you have a column where you have states in Nigeria, then you want to group them into geopolitical zones. You can do some stuff like that. So you can create calculated field. You can create calculated field. Maybe you want to calculate. So look at this is discount now. Let's say you want to calculate discount. This I think maybe this is calculated discount. So once you calculate the sales, the price of sales. Look at the price. This is sales. I don't know whether I have price here. Okay, unit price. So this unit price is discount. So you want to calculate the unit price after discount. You can do calculated field as regards that. Then which is going to be in another column. So there are lots you can do here. But if you want to do general data cleaning, you shouldn't. I wouldn't advise you to do data cleaning in this environment. But you can do manipulations, whatever you want to do, you can do it here. Then visualize your data. Are we still here? Hello. I want to expand. I want to expand. I don't want to presentation. I want to enlarge this. So I want to even put this in posting mode. So let me see that can. I'm not really sheet mode. Also, so let me just move. You can also add filters to this guy. You can do filter. Then you can say you want to filter by categories. So let's say this guy is also related to category, or this guy is related to as this guy is related to profits now. So you want to see the profits on in categories also here. So whenever I click on anything I click on here, it's going to be affected in this regard. So let's say you have so let me use Twitter. So let me use. So if you can, as you can see here, so if I click on furniture here, this is going to show the sales of furniture, average sales of furniture in this regard. If I click on offices here, you can see the graph has changed here. So you can see the average sales of offices in this place. If I click on all this one. if I click on this particular telecommunication technology, you can see that every series of technology here. If you also, it's also related in this, it's also changing in this map. You can see on Manitoba. Manitoba has 11,244 other countries. This is by office. If I change the furniture, Manitoba has 4,262. This is the essence of having a dashboard so that you can see the relationship of all these sheets together. So there are so many things you can do. This is not a tutorial for visualization anyways. So just for you to get acquainted with the Tableau environment. So that is by the way. That is by the way. Hello, are we still here?
Yeah.
Okay. I think I don't know what's wrong. The Mitayo is no longer with us. Okay. So that is what we for Tableau. You can explore more of Tableau. There are a lot you can do with Tableau.
Iman, can I ask a question, Iman? No, when we did the line graph, I noted that the numbers were that the graph was about 1,000 and above, but it started at say whether 100 or so. So the graph was not hanging up there. Thank God I brought it. Now you can see that approximately 2005, but the graph started from 0. Usually, if you draw a graph like this, it doesn't make much sense because it is expected that if it is in Excel, you will adjust the graph to start from 2000 so that it brings out the real features of the graph. Does this have that feature of enabling you to adjust the axis?
Okay.
So that instead of starting from 0, you start from, say, 2000. Does it have that feature?
I'm not explored that part, but
okay. Okay. Because if it's in Excel, you just click on that axis and it will give you option to adjust.
Okay, let's check it out. So let's
see, format, yes. That is it. That is it. So it will enable you to format the values. So that instead of starting from 0, you start from 2000. That's okay. I think I've gotten what I needed.
So I think we should be able to do that.
Yeah, you should be able, with that format, you can do it.
So just from here. Let's see, so let's put 2000.
Okay.
So, as you have suggested, it has changed. So I think that is
great. You can see
it
looks better. Yes.
So there is a lot we can do with Tableau. So let's just go on that. Thank you, Mr.
Okay.
So the next thing we're going to talk about is non-linear regression, because in real life application, your variable doesn't come, they are not usually linear. So sometimes your variables are not linear. So in that case, you need to use the linear regression to model. And you might not be able to use the linear regression model in that regard. So let's talk about the non-linear regression model. So in this to explain the basics of logistic regression, perform linear estimation using MLE, describe nonlinear regression, transform a nonlinear model into a linear model, explain the importance of generalized additive model. I don't know. Implement self-starting functions in RL, bootstrap nonlinear regression model, discuss some in-depth applications in nonlinear regression model. So let's get started. Even though we have exhausted so non-linear regression and generalized linear model. Different analysis is the process of building a non-linear function, predicting the outcome of a dependent variable on the basis of independent variables. The type of model parameters that depend on the degree of relation among variables. So, an example of non-linear regression model is the logistic regression model. So, when variance in sample data is not constant, or when errors are not normally distributed, generalized linear models are used to calculate non-linear regression model. So in that case, say your variables are non-linear in nature. So all generalized linear models are commonly applied in important types of regression. Count data expressions as proportions, which is logistic regression. Count data that are not proportions, as log linear models of count. Binary response variables, which is yes or no, day or night, sleep or awake, male or female, buy or not buy, respond or not respond. Data showing the constant coefficient of relation, e.g. time data, camera. Someone is that the topic? Or the interview is back. Okay, welcome back to interview. So you asked that which are the following example of non-linear equation. This is a linear equation. As you can see here, y minus a plus bx u. So u can be a constant. Y minus mx. This is supposed to be equal to, I think, either is y minus mx minus c. It's still a linear model. Ax plus by is also equal to also a linear model. But look at this, y is equal to c exponential bx times u. This is not a linear model. This is a linear equation with the exponential transforming in here. So I want to talk about exponential. All right, right. Okay. So y is equal to c log dx. The log model is also a non-linear model. So let's take for example. Let me take for example. Where is that? Where's my altitude? Let me take for example. Let's want to plot the consumption in million for this guy. Plot petrol data. So let me say log, log which is natural log petrol data percent consumer in million. So look at the plot of this guy. Look at the way it's going. It's going up, going down, going up. So this kind of look at this kind of this is not linear. This is not linear because if you want to draw this, how do you want to draw the line? How do you want to draw the line? So let's see. Let's compare to let's compare to this kind of plots now. So let's compare to kind of plot virtue data apartment income consumer. What am I saying? So let me start. Uh, let me tell this guy with let's say proportion or driver's license. So let's call this guy. Look at what we have here. Let me plot it to this guy. Let me try and plot it to this guy. Uh, so this is not in our first way. So this guy is not a linear equation because of the exponential constant that is there. Because of the exponential constant that is there, that makes it not to be linear. But this, when you have a combination of independent variables of this format, and you have just the constant and the variable, and you say it's a linear equation. But whenever you have maybe exponential or logarithm, or you have this x variable to be maybe x squared, then it's not going to be linear again. Let's take for example now. Let's take for example, I have. So let me go to my house today. Now let me create a sequence. So let me create a sequence which is one. I don't want to do 1, 2. So let me create a sequence from let x be a sequence from 1 to 2, but it's changing by 0.01. So this is x. Now let me plot x for you to see. So let me plot x for you to see. You can see how the graph of x is straight. It makes a lot of sense. Now, let me now do plot of x squared for you. You now see the way this guy is going to behave. X squared. That's x carat sine squared. Look at this guy. You can see that it's going down, then it comes up. Now, the starting point and the ending point. No, this is not what I'm supposed to use. This is going to make more sense when I use 0 to 1. Now, yes, 0 to 1. 0 to 1. Let me use 0 and 1 as starting points. So let me plot x again. This is how x looks like. Now let me plot x squared. Look at the way x looks like. Now let me reduce this interval again. Maybe 0.001. Let me plot x. X is as straight as this. So let me plot x squared. Look at the curve is becoming like denser. Let me increase the interval of this guy like this. Plot x again and plot x squared. Here's my x squared. You can see the way the thing is going. So in this case, is very difficult for you to plot this guy in a straight line. So this is a nonlinear equation compared to this. This is just a combination of x and a y
Hello? George. Is this guy changing the? I've changed already. Should we on again? There's no water now. Why will you change? What is he doing that you should change your yourself? What was he doing? No, we changed together. I want to know for that thing for granted. Danny? This was the community. Huh? The route. No, only 3 of us they do that work.
Hello, can you get them?
Hello, I can hear you now.
My network just my network, my just it's not just moving again. I have to use another PC like this. I don't know what's wrong. So I'll just continue from another PC. So I'm using another PC. So I'll share my screen now. I'll have to log in. Okay, log in. So can you see this? Can you see this? Hello, sir, can you see this? Can you guys see my screen?
I can see your screen.
Okay, if you can see this, so if you need the Tableau course, I think since you guys are registered, you should be able to see it is free. You should be able to access this. You should access this for free. Then
is it included in our curriculum? In the courses available to us?
It's not there. Tableau is just a session out of the curriculum. But this one now, you can enroll, and it's going to be added to your online platform. If you have this, you have access to this platform now.
Yeah, I have access to this platform.
So by the time you enroll and sign in, you should be able to access that course. So let me sign in. You're going to know what I'm talking about. So let me sign in. Okay. Let me see. So I'm signed in. So let me go to the next, the third column here. So you can see that Tableau has been added here. So if I click on resume course like this now, you're going to see something like. So this is an explicit tutorial where you can learn Tableau, article, adding calculated calculations to your workbook, mapping data in Tableau. So you can. So it's like an extra course you can access for free. So that's that. So let us continue to this course. Okay, we are here. So you're talking about nonlinear regression. Then we are okay, we're in slide 6. So this slide 6. Yeah. So we talk about logistic regression. Now, logistic regression is, identifies the relationship between the enumerated variables and capable of processing only a single value out of a given set of values and independent values using the probability theory. So this is how it's like. Logistic regression is by using the log fit function So the log digit of x, which is mathematically expressed as this, which is obviously not a linear model. So if P of x is the probability of occurrence of an event on the basis of an independent variable, so it means that probability of, it's just like maybe I trying to base whether somebody is going to buy a product or not. So if the person buys, then you have it to be 1. If the person does not buy, you have it to be 0. So okay, try to grab, okay, what's the probability of the person buying the product based on maybe the price of the product now? So your independent variable now is your price of the product. Now your dependent variable is the response. So in this case, maybe the person buys or the person does not buy, which is 1 and 0. So this display value of an event shows value of occurring an event based on the independent variable. So this is your independent variable x bar. So you have this expression. So applying the log function of p of x. So log of p of x is log of 1 over 1 minus p of x. In this case, your x is your x. So so you can also have multivariate logistic regression, and you have multivariate log function. So you have more than one axis. But you can say, if you want to put it that someone is going to buy your product based on the price of the product, and based on the person's income, and based on the also based on the, I don't know the kind of variables, and so you have two variables, price and income of the customer that is trying to purchase the product. So here P is the expected probability, x1 to xn are independent variables, and B naught and B1 are the regression coefficients attached to each independent variables. This screen looks very catchy than the one I've used before. It's interesting. Don't mind the background noise. So B coefficients need to be calculated in statistical analysis. For this, use the following steps: to calculate the logarithmic value of the probability function, calculate the partial derivative with respect to each, also adjust the math behind the how to calculate the beta coefficient. So let me see whether I can use the whiteboard marker here. So since this is a new I'm using a new system, let's see whether the whiteboard marker is going to function very well. Hopefully, let's hope this is going to come up. So logistic regression can be calculated with interacting variables, that is 3 or more variables in relation, where 2 or more independent variables affect the dependent variable. We use indicator variables, determine variables used to store values of an array, also in calculating the logistic regression. So in any which way, you are doing logistic regression. If your variables are categorical variables, you have to encode it. So that's when we talk about the domain variables. So we've talked about something like that before. So some of the useful logistic regression model adequacy checking techniques are these 4. Consider deviance, parsimony, classification accuracy, prediction accuracy. So regression lines are used for prediction in the logistic regression. So the same way we have regression lines in its simple linear regression and multiple linear regression. So let's see. Now, fitting the regression model. So use the generalized linear model in this case. So specify probability function we are using, which is in this case binomial. So trying to find occupied and resources. So in this case, you are saying, okay, what's the maybe you are trying to say what's the example, what's the 3D model? Okay, person is going to occupy a particular space based on maybe some particular resources. So you can draw drawing the logistic regression line. Here you are going to explain this one as we proceed in the session. Dividing the range of given values, blah, blah, blah. So we are going to see how we are going to do this as we proceed. Calculate the probabilities for divided range. Residual means to apply divided range. Residual means and vector of this means. Plotting the generated plots. So this is the independent variable resources. So plotting the points of residual means using the probability, which is the predictor, as a predictor, your dependent variable, the value you predicted, and this is the predictor variable. Let me go back again. Okay. So plot the generated points for the logistic regression line. So okay. Line estimation using MLE. So maximum likelihood estimation refers to the process of estimating the parameters of the regression model. So parameters can be estimated in any of the following ways: specifying model parameters with certain conditions such as stand. This one are just technical terms. You might not necessarily use this when you are performing your analysis. It's just for you to understand the commands you need to write and all that. So okay. So I'm going to do a practical session and guys that. So for the I don't have the virtual environment here. And I don't even have house to do here. Excuse. Transformation of a non-linear model into linear model. So let's take, for example, we have this model. Okay, so let's take, for example, you have this model. Now you want to transform this guy to a this is a non-linear model. I want to transform this guy to a linear model. So there are so many ways where you can perform a transformation. It's just for you to make that model that is non-linear to a linear model. Now, so in this case, we want to take the logarithm of both sides. So if we take the logarithm of both sides, that will be ln of y, which is natural log. Let me check. Okay. Still the same thing. I'm not seeing the pen. I'm just seeing the. I can't see the pen, but I can see. Let me use another. Another code. I can't see the pen, but I can see the white dot. Still same thing. Your status is set to. So let's just move on. So taking the ln of both sides, if I take the ln of this, which is natural log, it's going to be equal to ln of this. Now if you have something like what we call ln of AB is ln of A plus ln of B. That's logarithm, law of logarithm. Now in this case, so if ln y is equal to ln this, since this is c times exponential bx times u, since it is multiplication that is separating them, so you are going to have ln y to be equal to ln c plus ln exponential bx plus ln u. Now, ln exponential bx is going to give you bx because ln of e is 1. So you are taking ln of exponential, it's just like you are taking the inverse. So it's going to take out everything. Then what you are going to have is just bx. That's why you have bx here. So you have ln c plus bx plus ln u. So ln y is equal to, this one is supposed to be equality. So what you just achieved is you have just changed that model to a linear model now, because this ln c is just a constant value, plus b times x is a linear function now, unlike when it is exponential bx. Now you have plus ln u. U is a constant, ln u is just a constant. So you can even combine these two and add them since they are constant. So substitute y for ln y. So you can just, ln y is a value, it's just a value. So y will now be ln y. So c for ln c, you can just put c as ln c because c is a constant, ln c is also a constant. So just put as capital C and plus bx, then put ln u as capital U. So you can see what you have here now. So maybe this one is supposed to be capital C. So you now have what we call a linear model. So you just transform this, just successfully transform this non-linear model. So you can use this as, you can do simple linear regression with this guy now. So let's move. Let's consider the following non-linear regression model equation. Which of the following is the correct approach to convert this equation to a linear model? I think this is y is equals to a. I don't know. This is not looking, but take e base logarithmic of the equation. All it's just doing is that take ln of both sides. So you are going to convert this one to a linear model by taking the natural log of both sides, which is ln. That's this guy. So you can be asked this kind of question in the certification exam, so you should understand the concept behind it. But I don't know why my whiteboard marker is not working fully. So that is that. So other non-linear regression models. This is a non-linear regression model, ax over 1 plus bx. This one, since that's this exponential, it's already non-linear. This is another non-linear model. We call this one 2-parameter asymptotic exponential, 3-parameter asymptotic exponential, because you have a, b, and c. Because you have a and b here, so they are called 2-parameter, and this exponential. This one is called Michaelis-Menten non-linear regression model. Okay. Let's see the next slide. 2-parametric logistic regression. Because you have A and B. Now it is 3-parametric logistic because you have A, B, and C. That's exactly that. And here we have 3-parametric asymptotic exponential. It's not the same thing. It's okay. It says A over. So you have 3 parameters A, B, and C, and this is variable, which is A minus B exponential minus CX squared. Okay. I hope this is not the way they are going to put these guys in when I did this question exam, because it doesn't really.
It's like there is something missing in the asymptotic exponential, because both equations are the same.
Well, this one is different from this one. This one is A minus B exponential minus CX. But this is A over 1 plus B exponential minus CX.
It's the same thing with the 3-parametric.
Do you mean this one and this one
and 3-parametric? 3-parametric logistic and 3-parametric asymptotic, they are the same.
Okay.
And there must be something missing in the 3-parametric asymptotic, because it's exponential. They probably would have been in figures.
Okay.
Understand what I'm trying to say?
Yes.
There probably would have been an exponential figure attached to it.
Let me see. So this one, there's an error here. There's an error for this one here. And it's supposed to be exponential raised power b minus cx. But this one is b exponential minus cx. So I think that's the difference between these two. This one is exponential raised power b minus cx. This one is b exponential minus cx. I think you should be able to see that in your material. You should be able to see that in your material. This we can first order compartments, bell shaped by exponential. So you have a lot of them. So let's see to the next slide. So an example of non-linear regression, if you are trying to fit a particular data set, a txt super jaws.txt, maybe enter into this is actually messing up right now. So fitting the model, you use the NLS function, nonlinear model, to fit bone using this is 1 minus b exponential minus cx. This is a logistic regression. This looks like it's looking like the asymptotic exponential, 3-parameter asymptotic exponential. But help confirm in the material. So you have you stated the a parameter to be 120, the constant a, and the b coefficient to be 110, and your c to be 0.064 here. So you can check the summary of the model using the summary function. Fitting a simpler model, we put a model to be y equals to a times 1 minus exponential minus 6. So this one is let me check. Exponential. This one is x squared. That's the number. And these two parameter asymptotic exponential. 2-parameter asymptotic exponential. That's that guy. Yes. So applying the NLS command to the new model using this particular model. So you're building the model using this particular nonlinear equation, splitting the parameter a and c to be this. So you are using the h as an independent variable here. So I don't know what this point is, but when you enter into the particular class, so these are the dependent variable, and you are using h as an independent variable in this regard. So we have one model we have built here, call it model, and this is another model. Then you're expected to check the comparison between the model using the ANOVA test. So fitting the let me allow someone is okay. So we are going to talk about how you're going to go about this in the lab class. So which are the following equations represent the first order compartment equation model? That will be this. So I have not checked that out. But they shouldn't be asking this kind of question. In the examination, let us be guided. Let us be guided. All right, moving on. But if you go through the equations, you should be able to relate. Just have a kind of flashback of how the model looks like. Okay. Generalized additive models. So generalized additive models help in fitting non-parametric proof to the data without requiring specification about a certain mathematical model to describe non-linearity. So we use GAM command to implement generalized additive models with the model containing many of the attributes, this and this permits the modification of the result using update. So instead of me having to specify all these parameters here using the NLS command, I can just use the GAM command to do that. So let's see. Okay. So self-starting functions are used in nonlinear regression analysis to overcome chances of the initial guesses, which are the user trains to make being wrong. The self-starting models work out the starting values automatically. So instead of having me to state it explicitly, they are going to help us in doing that. So this gives the self-starting version of the Michaelis mental model, while this is for asymptotic regression model. Okay. So let's take I'm just trying to replace what we had over again. So let's just see the next one. All these things you cannot really get it from here. I think I'll just have to go to the practical. And so I'll just use, let me use the practical, the lab manual, lab solution to explain what I'm talking about. I'll try and start from this. This is my other system I'm not coming, and that's where the RStudio VMware, because this other system has been formatted. So I don't even have. Hey, seriously, I don't have the folder in this on this PC. So can who can help? Dr. Abeng, are you going to help us share your screen? Dr. Abeng, are you there? So that we can go through all these things together. Because
what do you want the data?
Not the data, the lab solution for this particular session, so that we can explain some things we have to do.
The lab? I don't have anything apart from what you shared to every one of us.
No, you know the folder that folder you zipped on the analyst folder. So the full snippets inside the folder, that's what I just need.
My analysis folder?
Yes, analyst folder, yes, sir.
If I share my screen, you will take me through, right?
Yes, we are going to go through that together.
Okay.
I will have called Susan to help us with that, but I think her mic is not functioning.
You know, I've not been doing much practical. I've not been doing practical with you. I always follow you. Because if I do it along with you, I'll be missing it. So I prefer sitting down and listening to you. Then later on, I have my. Are you seeing my screen?
Yes, sir, I can see your screen. Just minimize your yeah.
Okay. So what do you want to do?
Go to your analyst folder, sir.
Analysis from the download, right?
I don't know where it is on your computer. Maybe it's on download.
It was from here. And then down. Where is it?
Maybe you scroll down.
Down.
You can scroll down. Let's
Okay. Yeah.
Yes, that's the folder. Yes, sir. So open here. The first one, yeah. The first folder.
This code script.
Yes. So we are going to see. You can see the fourth text file, logistic regression.
1, 2, 3, 4. Okay.
Logistic regression. Yeah.
Should open it.
Then yes, open it, sir.
Should open it, right?
Yes, sir. Yes, sir.
Okay.
Okay, so this you are trying to do implement. So do you have your house to open, sir? Help me to open your house to.
My R.
Yes, house to.
I have problem with my R.
You have problem with your house to.
I have problem with my R, you know.
Why do you have problem with
My
your
VMR is not open.
No,
I've been trying to install this thing. Huh?
I'm not talking about your VMware.
Okay, the R Studio.
Yes, on your yes, exactly.
Okay.
So copy, first of all, copy all you have in that text file you just open, copy it. Control A.
I should copy.
Yes, Control A and Control C.
Okay.
Control C. You put it in the scripts in your house studio. Yes. Control V here. Okay. So first of all, I said we want to do a logistic regression, a simple logistic regression here. I want to use the ice cream sale. So first of all, sir, where that data set I sent to you, where is it? Is it under download?
No, it's still, I've not even removed it from my email. It's still there.
That's it.
And it's still in my email. I've not been able to remove it from there.
But you need to perform all this analysis on the data sets. I thought you have
I am trying, but sincerely, it's not easy on my part.
Okay.
It's not easy. So can we maybe if you are careful enough, I mean, if you are patient enough, it's already 1:30. I'll just go to my email and see if I can bring it out. But
okay.
If not,
can you quickly do that?
Okay, let me go to my mailbox, and I have to look for it.
Okay, don't worry.
Okay.
So the first kind of code here, we imported the sales-based data with ice cream sales. The second line of code here, we are trying to plot the age and the buy. Now the buy column is going to be something like maybe 0 and 1. Maybe 0 shows that the person buys, and 1 shows that the person then 0 shows that the person does not buy, and 1 shows that the person buys.
Ima, can I make a suggestion?
Yeah.
I think maybe either Susan or Temitope should have.
So let me just ask Susan.
Yes.
So let me ask Susan whether she has it. So okay, Susan, please share it. So I think that's to help us share your screen. Sam, please help me share your screen. Open your house studio, then copy the code snippet for the logistic regression to your script on your house studio so that we can see how far we can go with this. Susan, we are waiting for you. So I don't know. Is Susan not there? Dr. Abeng. Dr. Abeng, are you there?
I'm with you. It's just that I'm not seeing the screen.
And you are still sharing your screen. So
I'm sharing.
Yeah, you are still sharing your screen, but I want Susan to share her screen. I don't know where she is. I don't know what. But so since Susan is not, don't worry, don't worry. Just go to that text. Let's just.
I should go to the text.
Let me just see the text back since you don't have.
I should
share your screen again. I don't think we have Susan.
I should share my screen.
Yes.
I should share my screen.
Yes. Dr. Abeng, are you sharing your screen now? Hello, Dr. Abeng, are you there? I know you're sharing your screen.
Ima, can you hear me?
I can hear you, sir.
I don't know where the issue was from. Was it from me? But I couldn't hear you. I couldn't hear you for something. I've shared my screen. Let me do it again.
You can't see your screen.
Can you see my screen?
Yes, I can see your screen now.
Okay.
So, so the second line, we are trying to plot the age with the buy column. But we are trying to test whether a customer is going to buy a particular product depending on the age of the customer. Hello, Susan, can you hear me?
Yes, I can hear you. Can you hear me?
Yes, I can hear you now. So,
I don't know. It's still showing connecting on my side. I don't know why.
It's still showing connecting. What's connecting? What's that? Can you share your screen?
Can I stop sharing mine?
Hold on, sir. Susan, can you share your screen?
Yeah.
Okay, please help share your screen. So, Dr. You don't to stop sharing. If she shares her screen, your own presentation is going to go up. So you don't necessarily.
Okay.
Sorry?
Share your screen. You can share your screen, Susan.
Share your screen with us.
Susan, can't you can't share the screen?
I am already now. Can you see it?
Okay, is this your screen you are seeing? Or the garden screen?
This is very likely my own.
No.
This is the garden screen. It's not your screen.
Oh.
This is Dr. Abe's screen.
Okay, Dr. Abe, stop sharing your screen. Stop sharing your screen.
Okay.
Okay, let him stop his own first.
Yeah, stop sharing.
Should stop.
I think you have stopped now.
Yeah. I have stopped.
So how about now, Susan? Can you share your screen now?
Trying to know.
Susan, we can't see your screen now.
You can't. Oh.
So I guess since Susan can't share her screen and Dr. Aben doesn't have the data set and the internet network is bad, a bit the system, and mine, I have my system just got locked out and I don't know what I'm using before. But
You
this one
know.
I'm no, I can't see yes. You can see the share screen button, Abby. You can the share screen button, you can see it and it's allowing you to share, but you can't see. I don't know. Can you log out and log in?
You can't see it.
Can you check out of your class and check back in? Hello, Susan, do you hear what I said?
Yes.
Okay.
I'm trying to check again. What about now?
Hello, Susan, did you see something?
Can you hear me?
I can hear you. I can hear you.
Can you see now? Can you see now?
No, I can't see your screen. Maybe she leave. Maybe she leave the classroom and rejoin.
I should log out again and join.
Yes. So let's see whether that will work out. If it doesn't work out, then maybe we just continue.
Is it?
I said you should leave and rejoin. You should leave and rejoin. Let's see whether it will work out. Okay, let's see whether you can share your screen now.
Ima?
Yes, sir.
See, just like you suggested, if we can't get through, we can just end it today here, and then by next week, see how we can pick up from here.
Okay, but let's see whether she can see. Susan, can you share your screen? Okay, I think she can share now.
And today,
I don't know. Are you now?
Yeah, we can see your
Can you
screen
see
now.
now?
Yes.
Can you?
Yes, we can see.
So you want me
to
to go to the house studio?
Yes. So have you copied the lab? Or do you have your
Logistic regression.
yeah?
You have what?
Have you logged into your virtual lab already?
Do you want me to use the house studio? Which one do you want me to use?
Any which one? Any which is.
Can you see my screen now?
I can see your screen. Yes.
Okay. So I should copy the
text file.
logistic regression, right?
Of the post.
That's the lab one.
Yeah, everything just Control A. Everything Control A. Everything. Just hello. Just press Control yes. Control A. Copy everything. Yeah, Control B. Control. Yeah. So let's start from okay. So do you have this that data set I talked about that I sent to you guys? You have downloaded it already.
Can you see my screen now?
I can see your screen, yes.
Which one? You can see the house studio now.
Yes. So do you have the data set downloaded on your PC?
Yes, now I've copied it there now. The what you call it now, the logistic regression data set, or which one are you talking about? The one you sent or the one from the code script?
No, the one I sent, the data set I sent to you guys.
Oh yes, I do. I have it.
Which location do you have it on the?
Yes, I do. I have it.
Okay, you have it on. Okay, this is the location where the data set is. Okay, good. Okay, good. So go back to your house studio.
Okay, this is my house studio.
So run pwd. Get wd. Run get wd. Let's see the current working directory of your house. Get wd, then put into brackets, like open brackets and close. You don't need to run it at the extreme end. You don't need to go to the extreme end for it to run it. You don't need to go to the extreme end of your scripts for it to run it.
Extreme end.
I saw that you went to the extreme end of your code snippet to run the script. You don't need to do that. You can run it at okay, just get wd. Get and wd. So control enter. Okay. So copy this output. Copy this output now. Copy this output that you have.
Okay.
Now your directory. Okay. So Control C. So scroll up to your script. Your script file.
Should copy this one.
You have already copied it now. Just the directory.
I did not.
You didn't copy it to the okay. So go to your. So at the back of data sets, the first line of code, SQL is going to read your CSV at the back of data sets. So just copy that paste that in there.
Which of the data set now?
The first line of code that you have there, ice cream.
Ice cream, yeah.
At the back of data set, that data set line, that data set word. At the back of it, that's the front. That's the front. At the back. At the back.
After CSV.
Oh, after the CSV?
Yes, now that's what I'm saying. At the back. Control Z to undo. Okay.
Undo. Okay. Yeah.
So remove the. What did you do there? That's what I'm saying. That's what I'm saying, Suzanne. I said at the back, at the beginning, that at the starting of that, before this data set, you are putting at the extreme end.
I understand. You said at the back now.
Taking us to this other side now.
After
I'm confused now. You said at the back.
Hold on. After read.csv, you have data sets. Before you get to data set, that's after read.csv. That's what you want to put it. That's at the back of data
before
set.
the data set. That's before the. It was at the back of the data set before, which I did.
Undo, Susan.
You put.
Okay, so now you want me to put it here? That's just after.
No, I didn't say
CSV.
Yes, exactly. At the
which one is
data? Can you see the word data set? Before data set, that's at the back. Before data set.
Before the data set.
Yes.
Before the data set, that's just after the semicolon.
Yes.
The column.
Yeah, the quotation. Yeah, the quotation mark. Just put it there. You don't need to put space. Remove the quotation. Remove the quotation in that output. Don't remove the. Yes. Don't leave space.
You said at the back. No, there's a space there.
Yes. So remove the one in front of at the back of data set. So immediately after document. Remove the quotation immediately after document. So put a slash. Put a slash there. Don't put space. Don't put space. Put a slash. Don't put space there. So replace that document with desktop. So type desktop there. Then put another slash. Okay, I think it's fine. Put another slash. Then put DASCA, capital letter. Since that's the location of where you store the data.
Sorry?
Put another slash, then type DASCA, capital letter DASCA. So I'm trying to so capital letter DASCA, yes, exactly. Yeah, on it. That should pick up the no, before you go, remove that. Yes, remove that. Wait. You can set to alert or just move that greater than sign.
Just greater than sign. Okay, normally
That's
I just
that. Okay. So that has already reached your data set to the environment. So let's go to the next line of code and plot that result.
That's a plot, blah blah. Do I need to copy anything there or just run it?
No, you just run. So wait. You don't need to highlight. What I'm telling you is that you don't need to highlight. So there's this sign before plot. That's what I said you should remove. So if you just move that sign, just press Ctrl Enter. You don't need to highlight, just press Ctrl Enter, it will run it. You don't need to do exactly. So these are the now look at this now. This is not a kind of linear combination or linear relationship between the age and the buy column. But let us even look at how the ice cream data set look like. So one head of ice cream, head into bracket ice cream. So let's even see how the data set looks like. So try and run that.
Actually, which one?
Type head.
Next.
No, don't. Let's look at. Want to look at how our data set looks like. Head of ice cream. So head into bracket ice cream. So want to see the first. You don't
so you have to
type
type edge of.
You don't need to put it in the console. I just put it immediately after the plot command.
Edge, right?
Edge. H-E-A-D.
Oh, sorry, edge.
So of the data we plotted, that is ice cream.
Ice cream.
It will just give you the hints already.
That's all?
Yes, country enter. So I'm not still. So as you can see here, you can see you have 0 and 1. So 0 is like, okay, the person does not buy. Why 1 is like the person buys the product. So you have age. So these are the plot of this look like, and it's not a linear kind of relationship. So you cannot use the linear model for the prediction of this kind of stuff. But if you look at the next line there, you use the LM command, which applies the linear regression model. But actually, in the real sense, it's not going to work out. But let's go on the next line, next line of code. Yes. So let's go on it. Okay, it has built the linear model. Let's look at the summary. Let's look at the summary. Remove the yes and complementary. So this is how the summary looks like. If you see look at scroll down. So you look at the residual standard of multiple house squared, you can see it's not even. You can even see the values. Let's look at the values that the guy predicted. Let's look at the values that the guy predicted. Oh, this have been flexible if it was me that is actually doing this, but it's no problem, Jack. But okay, let's run the next command. Let's run the next command, which is results is close to that. So this is going to build the non-linear model, generalized linear model using the by as the dependent variable and the age as independent variable, family as binomial. So it's like, binomial is two outcomes. Is that yes or no? So in this case, it's buy or don't buy, which is 0 and 1. So let's look at the summary of the results. So this is the next line of code. So we have this results. So you have this is the intercept value minus 3.98. This is the intercept of the age, which is 0.13. But let's see. Type fitted results.
Fitted.
Yes, fitted, then into bracket results. And put results inside. Let's see. Run it, Ctrl Enter. So okay, beautiful. Now let's now check the original data set that we have. So let's check the buy data set. So type ice cream @ age. So one ice cream a percentage. You are typing. I said ice cream a percentage.
Ice cream.
That's our data, ice cream, then a percent. Then put the percent sign. This is the dollar sign. The dollar sign.
H or capital H or small h? Does it matter?
See, that's it. Capital
H.
Yes, H. So let's run it. So this is the original. No, sorry, not age. Buy is buy. I want to say buy, not age. Ice cream percent buy, not age. Sorry. Since that's just want to that's the original variable. Then the fitted result is the predicted variable. So do ice cream percent buy, not age. There we go. Buy, yes. Okay, this is what we have, and this is what we have. So run that fitted result again. Run that fitted result again. So go to the upper, yes, run it again. So let's compare. So let's compare the. So scroll up on your console. On your console. It's okay. Go down. Go down to that where you have the ice cream percent buy results and the. Is it okay? It's okay like this. Yes, it's okay like this. So you can see, if you can see the first two results in ice cream percent buy, you have 0 and 0. Now, if you see, if you can see the first two results in the predicted value, you can see 0.04, which is actually close to 0. It's working well. Then the second one, you have 0.37. It didn't really predict that one very well. But if you look at the third, the fourth, so everything else, the one that is close to 1, which is 0.98, 0.99. So you can approximate that to take it as 1. So it means that, okay, this person actually, so this guy predicted that this person actually buy the product. So the one that is close to 0, you can say, oh, they didn't buy. So you can use this kind of result. So as you proceed down, you are going to see some other analysis that is one on the data set. Look at the next one, you have the logistic regression model and all of that. But you might not be able to do all these things very, very well. Look at this guy now. I don't know whether you have this concordance.r in your data set. So you can, if you have it, you should be able to run all these things and try and relate it to. But in the next class, you are going to see, is it the concordance? Okay, you have it there. So if you should run it, you should work on your output. So that's why I send those. So you don't actually need to go through to get the VMware if you can do this on your normal local PC. So in the next class, we are going to continue from where we stopped. We are going to continue from here because of time. So Susan, thanks for helping us share your screen. But you guys should go through all of this, and we are just going to do a summary of what we have in this class, in the next class.
Okay, Iman?
Yes, sir.
Your audio for this week was not very good. I don't know, for the class, the audio was not very clear.
Is it this class?
From the beginning, yeah. For this class, from the beginning, it has not been very clear. I don't know whether it is the network or something.
Let's see.
I'm just drawing attention to it so that next week you work on it.
All right, no problem, sir.
Thank you very much.
All right, thanks for your time. Timitayo, thanks for attending. Susan.
Thank you, everyone. Temi, thank you, Susan.
So
thank
you guys download the data sets and try to work on it locally.
In the survey, I recommended that we can set up a WhatsApp group. So if I need
yes, exactly.
I can ask. So we don't have to wait till Saturday before we get things done.
Okay, yes, exactly.
Yes, so because I have one problem. My own problem is I don't have the time. That's the truth. So after today's class, probably check it today, then tomorrow I look at it again. Monday to Friday, man. There's no time. That's my problem.
It's the same problem here.
I don't have anything to say.
So, can you guys drop your contacts here so that I can just pin it down? So I'll just go to the WhatsApp platform and add you guys.
You have all our numbers now.
I don't.
You have it.
Okay, no problem. No problem.
If you don't have, you will get part of our school fees.
All right, no problem then.
I will drop it now because I might forget. I'm just putting the chat right now.
Okay.
So you guys just drop it in the chat to save us the stress of trying to look it out in the form.
Thank you, everyone.
Thank you.
Bye.
Bye, everyone.
Bye,
okay.
Bye.
Dr. Please drop it before you go. Okay, I think I have yours. I don't know whether your, you might have two contacts. I don't know which one is WhatsApp or.
No, I only have. I'm in Nigeria and I only have one number.
Okay, no wala now. No wala, sir. Okay, I think the Uganda is here. So Susan, are you here?